Hey guys, happy Thursday. We're going to start off today by learning about significance tests for proportions. This is day one. We're going to be kind of using what we've done and putting it all together to now actually run a significance test. So, we're going to kind of refer back to the day one activity we did with Mr. Easton right here. And our question is, are you sure Mr. Easton isn't a good free throw shooter? So in lesson 9.1, the first lesson we did, we used simulation to estimate a p-value to decide whether or not Mr. Easton was exaggerating about his free throw percentage. And today we're going to use a formula to find that p-value that we're pretty used to using. We're going to carry out a significance test. We're going to write those hypotheses. So back then we had said that p is the true proportion of shots made by Mr. Easton. Okay, and our null hypothesis was that, he really did have a free throw percentage of 80. He just had an off day. And our alternate would be that he was lying. It's actually less. So we just converted what we did in words now into numbers. The null is that the true proportion is 80%, and the alternate is Mr. Easton might be exaggerating. It's less than 80%. Number 2, each class found a different p-value because the dot plot was different, and that's true. They were close, but they were different. Would it be appropriate to use a normal distribution to model the sampling distribution of p hat? Justify your answer. All right, so this is asking us to check for normality, and for proportions, how we check that normal condition, remember, is n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. What's different than confidence intervals here is that we do know what p is, so we are using the actual parameter here, which is 80%. So 50 times 0.8 is greater than or equal to 10, that's true. And 50 times 0.2 is greater than or equal to 10, that's also true. So the law of large counts is met. So we're okay as the distribution is approximately normal. Are there any other conditions we should check? Sure. Technically, you should check that random condition, and we should check that 10% condition as well. The conditions for a significance test are the same as for a confidence interval. All right, let's look down here. Now that the conditions have been met, find the mean and standard deviation from the sampling distribution of p hat. All right, we're going back. We learned this in unit 6, is that the mean of the sampling distribution of p hats is equal to the population parameter p, and for us that's 0.8. And the standard deviation of the sampling distribution of p hats is equal to the square root p1 minus p over n. So in this particular situation, this is going to be 0.8 times 0.2 over 50. And that's going to be 0.05. Okay, it says use the mean and standard deviation you found to label the normal curve. All right, I'm going to go ahead and pause the video and label my normal curve. You can do that too. Okay, so just looking at my normal curve being labeled here, I can see that Mr. Easton's way down here. If the average is 80%, that 64% is way down here. So let's go ahead and mark that off where that 64% is. We're way in that lower tail. And for question 5, it says how many standard deviations below the mean is the p hat value? All right, let's find this. Remember, our z-score formula is c equals p hat minus p over that standard deviation. So we know p hat is 0.64, P is 0.80 and standard deviation is 0.056. This gives us a value of negative 2.86. Find the probability of an 80% shooter making 32 out of 50 or less. So I'm going to find the probability of P hat being less than, that's fine, 0.64, which is equal to the probability of a z-score less than negative 2.86. So I'm going to use normal CDF. The lower bound is negative infinity. The upper bound is negative 2.86. Mean of 0, standard deviation of 1. And this gives me out a p-value of 0.002. So right here, this is our calculated p-value. So it's kind of like we're putting everything we've learned together over the last many units. What conclusion can we make? We're going to compare p, which is 0.002, to our alpha level, which in this case is 0.05, I believe. And we notice this is less. Therefore, we're going to reject that null. So we actually do have convincing evidence against the null. We're starting to kind of think Mr. Easton's fibbing here. Okay. So what we did, let's just sum it up. We had a null and an alternate. We went ahead and calculated out the mean and standard deviation of the sampling distribution. We were able to find a z-score of that sampling distribution, and using that z-score, we were able to find a p-value that we could then analyze and make some kind of conclusion about how we feel about our claim versus our alternate or competing claim. One thing I also want you to know is that we are looking at being less than 0.64 here because we're looking at being less than 0.80. So I'm saying, what is the probability of getting an observation similar to what we saw with Mr. Easton or more extreme? And in this case, more extreme is the lower bound because the alternate is less than. Had it been greater than, it would be the opposite. So that is one thing to notice, is that whatever you're doing down here to find your p-value or your p-value with a z-score or regular data is going to match the alternate. Let's turn the page and let's get some notes done. All right, so here we are with some formal notes now. The conditions, we know what those should be. Number 1, we have the random condition. Number 2, we have normality, which for us is n times p is greater than or equal to 10, or n times 1 minus p is greater than or equal to 10. And last but not least, we have the 10% condition. N is less than 10% of the population. Okay, let's talk about the test statistic and p-value a little bit itself, just to make sure we know what's going on. All right, when we're talking about calculating a p-value, we need to make sure we know the mean and standard deviation of the distribution. Remember, the sampling distribution for proportion is normal, centered at mu sub p hat and sigma sub p hat. Okay, and remember, mu sub p hat is equal to the parameter, and sigma sub p hat is equal to the square root of p 1 minus p over n. If you want to find a z-score, you can do that by taking p hat minus p over the square root, p 1 minus p over n, and you use normal CDF to find that p-value. All right, now let's look at one other thing very quickly, which is what I just mentioned last, is for your alternate, if p is less than a number, you're looking at a lower tail test where more extreme values are going to be in the lower tail. If p is greater than a number, you're looking at an upper tail test where more extreme values are in the upper tail. If you're looking at P not equaling a number, which we're going to actually save for later, you're looking at a two-tailed test where we have some probabilities split between the two tails, so we would need to multiply by 2. But we'll just keep that on the table for now, and we'll bring that up a little bit later. So based on what your alternate is, you can kind of decide which direction you should use normal CDF. This lesson, we're looking for more extreme values in the negative direction, and greater than, we're looking for more extreme values in the positive direction. All right, so I'm going to go ahead and pause right now and let you guys do the U-try and come back and check your answers. For sake of completing this problem in a simple way, we're not going to be using not equal to, so you have to decide if the context implies less than or greater than. Okay guys, so let's check our answers. P is the true proportion of students in high school who have a part-time job. The null is 0.25 because that's what we're reporting. The Census Bureau has said for all high schoolers. And less than 0.25 is implied because we're looking at the proportion right here is less than the national figure, so that lets us know this is less than. Calculate our p-hat value because the sample is 39 out of 200 students. Our sample was random. The normality is checked. 200 is less than 10% of all high school students is assumed. Here's our statistic right here. The p-hat value is 0.195. That's 39 out of 200. Minus p is 0.25 over the standard deviation gives us a value of negative 1.96. We're looking at more extreme values, which are less than the one that we calculated, and the probability of that occurring is 0.036. And that is less than alpha, so that gives us convincing evidence against the null. So there's evidence to suggest, or the data suggests, that the true proportion of students in high school who have a part-time job is actually less than 25%. All right, so on your homework tonight, you're going to be doing some questions very similar to this with some interpretation. We're going to avoid using not equal to questions at this moment in time. Just based off the context, try and choose greater than or equal to for your alternate. And that's it. I hope you have a great day. Bye.